Welcome students. Today we are going to learn standard ninth subject science and technology part 2 lesson number 18 observing space telescopes. So let's start learning with the topic human curiosity to know about space. From early days man has been curious about the sun as well as moon and the stars seen in the night sky. Using his boundless imagination, he tried to understand the sky as observed by the naked eyes. He noticed that the position of the stars changed with time and had something to do with the occurrence of seasons. As the knowledge of the cycle of seasons was necessary for agriculture, sky watching began to prove useful to him. The position of constellations was also useful to seagoers for navigation. Man began to make determined efforts to find answers to the questions which arose out of his sky watching. But he did not have any equipment to get a closer view of the stars and planets in the sky. But today, 400 years after Galileo's use of the telescope, tremendous progress has been made in telescope technology and in space science and technology on the whole. This great leap in the technology has helped to construct for us an amazing picture of our universe. Space, science, and technology are not only important for research purposes but also to help provide us with many of the comforts and facilities we enjoy in our everyday life. A telescope is used to observe the space. Before to know about the telescope, let us have glance upon different forms of light. Light is an electromagnetic wave. Every wave has a characteristic wavelength. Our eyes can see only that light which has wavelengths between 400 nanometer to 800 nanometer. Such light is called visible radiation. However, there are electromagnetic waves of wavelengths other than the visible ones, most of which we cannot see as our eyes are not sensitive to them. Depending upon the range for the wavelength, there are different types of radiations like radio waves, microwaves, infrared waves, visible light rays, ultraviolet rays, X-rays and gamma rays. Of all the above types, our eyes are only capable of seeing the visible radiation. Thus, we use the visible radiation telescopes, that is optical telescopes, made from regular lenses or mirrors to see the visible radiation coming from the space. However, many heavenly bodies emit radiations other than the visible light. Thus, we need different types of telescopes like the X-ray, gamma ray, and radio telescopes to receive such radiation and to study their sources. So, let us learn in detail about the construction and function of the different types of telescopes. There are mainly three types of optical telescopes. First is refractor telescope, second reflector telescope, and third catadioptric telescope. Refracting telescopes are made up of only lenses, while reflecting telescopes are made up of mirrors, while catadioptric telescopes are made up of both lenses as well as mirrors. Let's look upon the construction and working of refracting telescopes. Most optical telescopes are made with the two or more lenses as shown in the figure. To collect the maximum amount of light coming from a heavenly object, the objective lens should be made as large as possible. Using the light collected by the objective, a smaller lens called eyepiece produces a large image of the source. Light rays change their direction as they enter lens from the atmosphere and again when they enter the atmosphere after passing through the lens, and this is called refraction, and hence such telescopes are called refracting telescopes. Even though such a telescope is useful for space observations, it presents certain difficulties. As we saw above, if we wish to obtain a bright image of a source by collecting the maximum possible light from it, the objective lens must be made as large as possible. However, it is very difficult to make a very large lens. Also, large lenses are very heavy and tend to get distorted. Also, as the objective and eyepiece are placed at the opposite ends of the telescope, the length of the telescope also increases with increase in the size of the lenses, and the telescope becomes difficult to manage. The images formed by the lenses have errors of colors. This is called chromatic aberration. To overcome these difficulties, telescopes are made using concave mirrors. As light rays get reflected by the mirrors in these telescopes, they are called reflecting telescopes. In order to get a bright image of a source, large mirrors are necessary. But it is easier to make large mirrors as compared to making large lenses. Also, big mirrors can be made by combining several smaller pieces. The weight of a large mirror too is less than that of a lens of the same size. The images formed by the mirrors do not have errors of colors. Only by using these large telescopes we can see far away stars and galaxies, which we could never have seen using our naked eyes. There are mainly two types of reflecting telescopes. First, Newtonian telescope, and second, Cassegrain telescope, as shown in the figures. In the Newtonian telescope, light rays coming from the space are reflected by the concave mirror. Before these reflected rays converge at the focus, they are deflected again by a small plane mirror. As a result, they get focused at a point lying on the perpendicular to the axis of the telescope's cylinder. They pass through the eyepiece and we get a magnified image of the source. While in Cassegrain telescope also concave mirror is used, but here the light rays after reflection from the concave mirror are reflected back towards it by a small convex mirror. They pass through a hole at the center of the concave mirror and then through the eyepiece situated at the back of the mirror. The eyepiece gives us a magnified image of the source. In this way, by using the refracting telescopes and reflecting telescopes, we can observe the heavenly bodies which are located far away from us, from the earth's surface. Thank you.